All right, what I'm going to do is I'll start with the easy stuff. Fair? If you don't understand something, raise your hand and I'll go over it again, okay? Abdul, I know you're checking your email. Excellent. Staying connected. That's part of success in life. It's part of your success in physics. Connect later. Understood? Excellent. You're wonderful. I don't care what anybody says about you, especially Zaytun. You're great. Okay, now, so let's begin. Now, we know what some of the, oh, by the way, not for nothing, but chapter 25 is on sound and light. It's a general chapter. This test is not on sound. It's on sound and waves, vibrations, right? Waves and vibrations, right? So it's waves and vibrations, and then it's on sound. Light has waves and vibrations, etc. Clear? Just wanted to make sure you get that, okay? Now, let's talk about some simple things that we may not have stressed, but are very important. Vibrations. And vibrations are, light is when you have charged particles vibrating, right? That's how light waves are produced. The vibration of charged particles. That's it, nothing else, okay? However, sound is vibration of matter. For instance, I have this, right? That's periodic. I know it's going to drive you crazy. I'm almost finished. That clap, the noise you hear is the compression. So the noise you hear is this. Okay, it's here. It's the compression. Clear? That's the, when you hear the noise. Okay, crest of the wave. Crest of the wave. If you want to convert a longitudinal mechanical wave to a transverse wave, right? You can make it sinusoidal into a sine wave, correct? Crest, 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 crest. Trough, crest, trough, crest, trough, crest. Get it? So, compression, rarefaction. Compression, rarefaction. Yes? So, you can see that it's actually simple harmonic motion. And when you think of simple harmonic motion, the first thing I think of is a pendulum. Is a pendulum. So, what is a pendulum? A pendulum is, as we talked about it in the chapter, etc., it just swings back and forth, right? Anybody play the piano in here? Metronome goes back and forth. Anybody? John, you have a metronome at home on your piano? It goes like this, right? And it probably clicks so you can hear it, right? Click. We used to have one here. It's probably somewhere. I should pull it out. It's a metronome. There's a little weight on the bottom, right? And you wind it, you know. Click, 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 right? It's actually a pendulum, yes? But when you think of a pendulum, you think of something, if I take a pendulum and I suspend it, and I put it right here against my nose, and I let it go, there's not a lot of friction involved, so it's going to come almost to my nose, at least on the first couple of tries. It's a little scary. I used to have this giant pendulum at a school, and I used to have students stand at the board, and I would hook it up to the ceiling, and I would put it right by their nose, and I would let it swing, and when it came back, they would dive. They thought it was going to hit them in the face. But in actuality, conservation of energy is not going to go any farther than this, because that's where it started. Clear? Yes?
Yes.
And that's, a pendulum is also simple harmonic motion. If I took a pendulum, if I have a piece of paper going like this, it's traveling at a certain speed, okay? The piece of paper is traveling at a certain speed, right? And the pendulum is, there's a pen hooked up to the pendulum, and the pendulum is swinging like this. What are you going to create on the paper? The paper's moving like this, the pendulum's swinging like this. What are you going to make on the paper? I can't do this and this at the same time. Right? What are you going to make on the paper? You're going to make this. You're going to make that. You're going to make a sinusoidal curve or a sine curve. Clear? What's the difference between a sine curve and a cosine curve? Anybody? My most wonderful pre-calc students. I can't erase anything yet, but this is 0. That's 1, right? It's -1, +1. A sine curve starts here, right? Right? Yes? Right? The cosine curve starts here. It's just where the starting point is. That's all it is. It's nothing else. It's easy. Easy peasy. Okay? I know. It's one of my great failings in teaching. Terrible at art. Terrible at drawing. You'd think I'd be better as a physics teacher after doing this for 40 years. Okay, so we have simple harmonic motion, a pendulum swinging. Okay? We know what amplitude is. What is amplitude? It's the distance from where to where? From the x-axis to the crest, correct? Or from the x-axis to the trough. Yes? From the node, right? The x-axis, right? You get that inflection, right? Comes like this, right here, the inflection, the node, right? So we know what the amplitude is. The period is the what? Define for me period in the simplest way you want to. No judgment. The period is the inverse of the frequency, right? The frequency is waves per second, waves per unit time. The period is how much time per one cycle, right? Frequency is cycles per 1 second, right? Cycle, how many cycles per second? That's what frequency is, right? And period is the amount of time for one cycle. Yes? You get it? Okay. So we know what period is and we know what frequency is. Any question on frequency? Any question on wavelength? No? Really good. I'm glad that you're completely in control of your pencil. Okay, excellent. Okay. So, the next thing, a couple definitions. Frequency can also be referred to as what two things? I'll give you a hint. Yeah, the pitch of the sound or the note. Yes? Has anybody ever heard music before? Okay, I'm just asking. I don't know. Sometimes you never know. You never listen. You don't want to take anything for granted. Right. I know, right? Don't take anything for granted. All right, so I have a horn and I have a guitar. They're both playing a C note, let's just say. But they sound different, don't they? They don't sound the same, do they? Right? First of all, if you know something about music, you might be able to figure it out. How many people know nothing about music? Raise your hand. I mean, I'm not talking about music appreciation. I'm talking about notes. You can play a few instruments. You know nothing about music.
I can play my mouth.
Yeah, okay. Well, I don't know anything about it. Man, plus I'm tone deaf, can't sing, have no idea. But I don't know. When I hear a horn blow or a guitar play, at the same note. It doesn't sound like the same, I couldn't tell. But what is it when two musical instruments, two different musical instruments, play the same note, but they sound different? What's that called? We went over this, by the way. I know.
I remember the question.
You don't know the.
I remember the question you asked.
You don't know the question as opposed to maybe
I said,
talking
I
to.
remember the question you asked last class about this question.
Yeah. Well, if you have two musical instruments, two completely different musical instruments, playing the same notes, but to the untrained ear they sound completely different.
It's because of the tempo.
Because of the what? Yeah, the timbre of the instruments. The timbre. That's what the difference is. Same notes, different instruments. One's a metal, brass, horn. The other one is a wood, acoustic guitar. Okay. So pitch, note, and frequency. Yeah. Okay. What about sine wave? Went over that. Yes. Sine wave. The transverse wave. Light is quite naturally a sine wave. I can convert a longitudinal sound wave into a transverse sine wave.
Yes.
Transverse waves, periodic mechanical waves, those are sound waves. Yes? Now, let's talk about one other thing, and it's going to be up here, and that is that what type of material does sound travel best through? Travels best through air. What?
Iron.
Yeah, I mean, there are probably better ones than iron, maybe, but it's got to be a combination of density, and elasticity. It's got to be a combination of density and elasticity. Believe it or not, air is elastic. It's elastic.
Someone is on the door for you.
Okay. Could you stop that?
Yep.
Just real quick.